Hello again. Thank you very much for joining us today for the webinar by Professor Jan-Louis Kruger and Dr. Sixin Liao from Macquarie University. As you all know, the topic of today's presentation is quantitative methods in translation studies, conducting eye tracking research. And we have two excellent presenters today with us who have agreed to share their expertise and also give us some of their time. Professor Jan-Louis Kruger is Professor of Linguistics at Macquarie University and extraordinary professor in the upset focus area in Northwest University in South Africa. His research focuses on the processing of language in multimodal contexts, specifically in audiovisual translation, reading, and interpreting. His main approaches are aligned with cognitive psychology and psycholinguistics. Primarily, his projects focus on investigating cognitive processing when more than one source of information have to be integrated, as in the reception of subtitles or the production of interpreting. He's on the editorial board of the Journal of Audiovisual Translation as well. Dr. Sixin Liao is a postdoctoral researcher at Macquarie University. Her research uses eye tracking to study multimodal reading, such as reading subtitles in videos. Her current projects also explore the use of subtitles as a reading intervention for literacy development. One of her latest publications on trends in cognitive sciences explores how digital technology affects the way we engage in reading. She is also a reviewer for several journals, including Target, PLOS ONE, and Applied Psycholinguistics. Once more, thank you very, very much for giving us your time and sharing your expertise with us and the participants. The floor is yours, Jan-Louis and Sixin. Thank you once more.
Mustafa, thank you very much, and thank you for having us. It's an honor to present on your platform, and yeah, we hope that that the participants will learn something from this. Apologies just in advance. I'm still getting over a nasty cold, so I may have the odd cough. Okay, so as the title says, we are going to talk to you today about quantitative approaches to translation interpreting studies. Now, this is not something new. It's not something that was invented even recently. It's been around for quite a long time, but we also know that this is quite a daunting area to go into if you didn't have the training to do so. And today is really just about maybe trying to dispel some of the myths around this and to maybe just show people a little bit about what it is and maybe take away some of that anxiety about using it. And maybe even more importantly, giving you a sense of when you should be using something like eye tracking in quantitative approaches and when you should maybe just avoid it. Because of course, it's not something that everybody has to use. It's one tool to give us answers to certain research questions, but we have to know that it's the right questions. So yes, eye tracking is popular technology. It's something that's become very fashionable, especially in the field of applied linguistics and translation studies. And over the last, I'd say, at least 10 years, it's become really popular, and it's understandable. There are an increasing number of experimental studies being conducted in translation interpreting studies, and I think this is a good thing. It's a good thing because if there is a question that can be answered experimentally, then we need to answer it experimentally. We can't philosophize about it if there is an empirical answer. Unmuting myself. There. Can you hear me? Okay. So where was I? what I was saying was, if you can answer a question empirically, then you really should be answering that question empirically. I think there are too many studies out there where people make wild claims on something that could have been tested experimentally, and they don't test it experimentally. So I think that's basically what this is about. It doesn't mean that quantitative research is better than qualitative research. It just means that it's another tool, and ideally you want to combine qualitative and quantitative research to get to questions. So there are some warnings to begin with. And the first is that eye tracking is not easy to use. You need to get training to use it. It's time intensive. It's resource intensive. You may spend months and even years collecting and cleaning data to answer one very simple question. And then maybe at the end of it, you realize that you made a mistake at the beginning and your results are useless. So it's really something that you have to approach with caution. You do need some statistical skills. The statistical analyses need to be rather sophisticated. So we're going to just very briefly focus on some basic eye movement measures, what these measures can tell us. We're going to talk about some of the main principles of data analysis and interpretation. And then Sixin is also, I think, are you still going to talk about ChatGPT? Yes, and just say how you can make ChatGPT your friend in this domain. Okay, there we go. So the basics about eye movements is really that there's a logic to it. There's a logic to using eye movements to study translation and to study, well, in the many domains in translation studies, in interpreting, in translation, and in audiovisual translation. And the reason for this is that a large part of the world around us is understood through our eyes. It's by looking at the world that we can understand the world. So reality as we perceive it, for those of us with sight, reality is largely perceived from through our eyes, and it's a first-person perspective. So, I mean, this kind of goes without saying, but didactically and logically, we interpret the world from our own didactic center, from where we are. And this is why looking at people looking at things can teach us a lot about what's happening, about what they're attending to, about what they're thinking even. And as I say, this is what's making eye tracking powerful. It somehow allows us to get a glimpse into the mind of the observer, even if it is still indirectly. Now, the reason for this is what's being called the eye-mind hypothesis. And it basically means that when a participant looks at a word or an object, they also simultaneously process that word or object. And they process it for exactly as long as they are looking at it. So when you look at something, you think about that. The way that Justin Carpenter formulated this is there's no appreciable lag between what is fixated and what is processed. So the way we look at something depends, something we have to keep in mind is that the way we look at something also depends on why we are looking at it. What was the instruction to look at it? If your instruction is to search for certain information on a page, then you're going to look at it differently from if the instruction is read this carefully because you're going to get some comprehension questions afterwards. A lot of the information, most of the information that we need from looking at something, we take in through our eyes. That's a silly thing to say. What I mean is, while you look at something, while you're making fixations on something, you are extracting information that you can use to interpret what you're looking at. And in reading, for example, we look at almost 70 to 80% of the words in a text we fixate. So it means that we actually have to look at almost all of the words in order to be able to understand what we're reading. But we'll say a little bit more about that in a moment. So why should we use eye tracking? I mean, there are many reasons not to use eye tracking. It takes a long time to master, as I said. It requires funding. It requires access to an eye tracker. And it requires relatively advanced statistical skills. So again, not something to be entered into lightly, because you have to know that this is going to take some time to do. but it can be really rewarding because it provides us very important information on text processing. It can tell us something, for example, in interpreting about how people make use of visual inputs during simultaneous interpreting. If there are maybe handouts or there are slides, how do interpreters make use of that? It can tell us something about how people divide their attention when they're reading subtitles, divide their attention between what's on screen and what's in the subtitles. It can tell us in translation process research, it can tell us how people divide their attention between the source text and the target text. So there are many really useful facts that we can obtain by using eye tracking. And therefore, it allows us to test certain assumptions. Some of the other reasons to use it is, as I said, if we can test something empirically, we should, but it also helps to develop translation interpreting as a discipline because it allows us to get into high impact journals, into journals in the field of maybe cognitive science, psychology, wherever. And I'm not saying one shouldn't publish in translation interpreting journals, but you can also see, if you were to analyze it over the last 5-10 years, how empirical research and quantitative studies have started becoming more commonplace in translation interpreting journals as well. And the last reason to use it is that it is fun. It is cool to use it. You can really find out things that are very difficult to find out otherwise. It kind of gives us one bit of access to that black box that is the mind of the translator interpreter. So what is eye tracking? Eye tracking is the study of eye movements of participants who are engaged in reading or scene perception. That's not, of course, the only reason, the only way, or what it's not the only thing it is, but in our field, looking at translation interpreting, we typically look at reading, we look at scene perception. The main measures in eye tracking, and I'm going to repeat this a number of times because it's important, are first of all fixations. Now, fixations are those periods of time when you look at something where the eyes are relatively still in one point, in one small area, and during that time we extract information. Now, we may have the idea when we look around us that our eyes move in a smooth path, but in fact we make very rapid movements with our eyes, which are called saccades, rapid movements between fixations, and then we stop, the eyes stop, and at that time where it stops, you extract information in the fovea, in the center, but also peripheral information around it. Fixations then, and in fixations, we measure things like the fixation count, how many fixations are made in a certain area, how long these fixations are. When you sum them all in terms of the average fixation duration, and also where are these fixations. Those are the important aspects in terms of fixations. Saccades, during saccades, you cannot extract information. It's kind of like you've got a momentary blindness during a saccade. You don't take new information in, but of course you can still process things cognitively because you can keep on processing what you saw in the fixation preceding the saccade. In saccades, we look at number of saccades. We look at the amplitude or direction of the saccade. Is it forward or backward? We look at the speed of saccade, things like that. Then in eye movements, less common measures are things like blinks. Every time you close your eye, that on the one hand creates noise, but it can also give us information. If people blink more or longer or less, then it can tell us something about how they're processing something. A little bit more difficult to interpret. And then we have pupil dilation, which can be a really good indication of cognitive effort. The wider the pupil is, the bigger the pupil is, the more information you take in. And typically, if somebody is really looking at something intently, then their pupil will increase in size. And there we can look at the percentage change in pupil diameter from a certain baseline. And it can be reliable, but the thing is, it is susceptible to all kinds of influences, like drinking coffee or taking any other stimulant will impact the way that your eyes dilate. your pupils dilate, whether you're tired or not, all kinds of things. But I'm not going to delve into that any further. Now, just getting back to saccades then. Saccades are, as we said, non-visual intake events, and they typically last between 10 milliseconds and 100 milliseconds, so really short movement, and that's why we're not really aware of them. If you think about it, it's not something you're aware of. Not aware of moving your eyes because it really fast that movements are really fast. You have saccades can be forward or they can be backwards. If it's backwards, then it's typically a regression. Now, when reading a language like English, your saccades would be from left to right. If you read Arabic, it will be from right to left. And then a regression is in the opposite direction to reading. And regressions can also tell us quite a lot about how people are reading. Saccades are typically between 7 and 9 character spaces. And that coincides with the perceptual span roughly. So if you look on screen, for example, at the M in major on the slide, then you can still see up to about the middle of types of the next word without moving your eyes. You can still make out those letters, but you cannot see movements, you cannot see I, because you can't see that far. You have to move your eyes through the text in order to extract that information. So a saccade is typically about 7 to 9 character spaces because that will then drive you through the text so that you can extract all the information you need. And then about between 10 and 15% of eye movements tend to be in the opposite direction of reading. And that is simply because we try to, you read something and then you realize you misinterpreted and you have to go back and reread, or it's a low frequency word that you passed very quickly, and then 2-3 words later you realize you didn't quite get that and you have to go back. So reading typically involves quite a lot of saccades as well, regressions as well. Fixations as the visual intake events are, as we said, when the eyes are relatively still in a certain area. They last in reading between 200 and 250 milliseconds. And but they have a very wide range. They can be 50 milliseconds, they can be 500 milliseconds during reading. Now, this is something to be aware of, and this is a mistake that's often made by novices using eye tracking, is fixation duration is a very useful measure. It can be, but your fixation durations when you read text are very different from the fixation durations when you look at a scene. So let's say in studying subtitles, or looking at subtitled video, we can't compare the duration of fixations while people are looking at the screen to the duration of fixations while they are reading text, because they're different activities. Reading, you need many short fixations. When you look at a scene, you need fewer fixations, but they need to be longer for you to extract as much visual information as you can. Okay, so then just as a summary of what these measures can tell us, and it always depends a little, so you have to be careful with these, but fixation counts during reading or scene perception can tell you something about attention allocation. So how much attention did somebody award to a certain stimulus? We can tell us something about the depth of processing. If you have more fixations, then obviously you processed it in more depth. Fixation duration, again, can be depth of processing. And in reading, when we look at something like a word frequency effect, we know that words that are less common typically attract more and longer fixations than words that are very common. We don't need to look at common words that we're used to as long as we need to look at words that we're not that used to. So in that sense, a longer fixation will tell us that there was more cognitive effort, more cognitive load involved. Saccade length can also tell us something about the depth of processing. If you have really long saccades, it means that you may be reading very fluently, or you might just be scanning through a text. Typically, if you just scan through a text, you will have very long saccades and you can skip more words. The saccade direction also gives us an indication. If you have more regressions, then you're not reading as fluently. as when you have fewer regressions. And then if you look at something like subtitle reading, crossover count can also give us an indication of the number of times that you switch between the subtitle and the image. Can tell us something about how you're processing the subtitles. Then word skipping. We can take word skipping as, again, a measure of the depth of processing. If you skip more words than you typically just scanning through text. We can look at things like the wrap-up effect, which is when you reach the end of a clause or a sentence, you tend to have a longer fixation on that last word because you are integrating the information that you just obtained from that clause or that sentence. So that can tell us something about the fact that you are busy integrating the sentence. Then the word frequency effect, as I said, that you will look longer and have more fixations on low frequency or less common words. That can give us an indication of lexical integration, that you are integrating the information. And then, as I said, saccade direction can tell us something about fluency again. So when do we use eye tracking? When should we use eye tracking in translation interpreting studies? Some of the topics where it can be useful are things like the attention distribution between the source text and the target text in translation process research. For example, even how do you make use of resources like dictionaries while you're translating? There you can look at things like the percentage dwell time on certain areas, the number of crossovers between those areas, the latency between reading something and starting to type, or reading something and starting to sight translate or interpret. And you can often combine that with things like keystroke logging. Then you can look at attention distribution between subtitles and video. We've done a lot about in that area, Sixin and I. And again, there are a number of measures you can use there. Then you can look at cognitive load during interpreting, during simultaneous interpreting. There you can look at things like, even though you're not processing, you're processing mostly auditory input. By looking at people's pupil dilation, you can get a good idea of the cognitive effort that they're experiencing. And you can look at their blink rate as well. Then you can also look at cognitive load during reading. And that would be if you have more longer fixations, then you are processing it in more depth, and it might also be that there's more cognitive load. And then, of course, it's really useful to look at eye movement control during reading of either a source text or a target text. And in that context, you can make use of global measures, such as what are the total fixation count across text, the fixation durations, the saccade length, the average saccade length across the reading of a text, the direction of saccades, the skipping of words. And then you can also look at local measures such as word length, word frequency, wrap-up effect, and so on as markers of lexical processing. So when do we use eye trackers in translation interpreting studies research then? First of all, you use it when you have one. You need an eye tracker to be able to use one, or you need access to one. Most psychology departments do have these. Increasingly, departments of linguistics or languages tend to also get access to these. You have to know how to build an experiment. It's not impossible to do. I mean, Sixin, when she started with her master, she didn't know how to use an eye tracker. But she read the manuals and she looked at the videos and she taught herself largely. So it's possible to do that, but it takes a lot of time. You have to have the time and the resources. And more importantly, you need to know that this is the right methodology for your research question. It doesn't help to use, and I've seen too many studies where people use eye tracking where there would have been much better ways to answer their research questions. Even a comprehension test would have been better than using eye tracking in some cases. You have to know that eye tracking is the right methodology for your research. And you have to be able to do some statistics, and you have to be able to answer the so what question. What does knowing how people move their eyes tell us that's relevant to our research question? Oops, I just lost my screen for a moment. So it's important not to use eye tracking simply because you can, or simply because you think it's cutting edge, or simply because you have one. I use it to answer questions such as, what is the impact of translation strategies, or text properties, or the modality of inputs, or motivation on eye movement control. And also on depth of processing or distribution of attention. You can ask questions about what elements of a text are prioritized during the reading in a multimodal context. When you are interpreting with notes, which aspects are you focusing on in reading your notes, for example? And you can answer questions like, how does language proficiency impact reading during translation? Something like that. So there are a number of limitations. It's not the panacea of translation interpreting research. It cannot tell us whether a comprehension difficulty leads to comprehension failure or comprehension success. It cannot reveal the thoughts or the opinions on what's being viewed by a participant. For that, you need something like a think aloud protocol. We cannot infer specific cognitive processes directly from eye movements. It's an indirect process. We know that in order to be able to process something, somebody had to have looked at it. But having looked at something doesn't mean that you were paying attention to what you were looking at. And that makes it difficult to just take somebody at their sight. You can't say what you looked at is what you thought. But you have to be able to look at something to be able to process that. You need to have careful research design. This is informed by evidence-based theoretical models. And this is another thing in translation interpreting research. We need to be aware of the cognitive models that inform why we are using these measures. And then the last slide from me. Eye tracking in translation interpreting studies research is a really good example of the challenges and the rewards of conducting interdisciplinary research. Translation studies has always been an interdisciplinary discipline. Using something like eye tracking means that we engage very actively with interdisciplines like psychology, like cognitive science. So it's a good example of that. It combines really tightly controlled experimental research with real-world or ecologically valid studies. And this is where we kind of in between disciplines. We're not really like cognitive science, focusing on very abstract, purely controlled, pure experiments, because we know that our research has to have application value to the practice of translation interpreting. But we have to know that we should not only borrow methods from other disciplines. We have to make sure that when we borrow these methods, we do that properly. And that's maybe my main word of caution here is to, if you are going to use eye tracking research, make sure that you do your homework, that you read up on how exactly to conduct it, how to report the data, how to do the statistical analysis, and how to report those statistical analyses. Now, if we do all of this, it will allow us to add significant value to the study of moving image, of reading, of translation, by combining the criticality and the creativity of the humanities with I wrote this sentence a long time ago. I have to look at it more carefully now. But the point is that using eye tracking is a really rigorous approach to research. And it's really useful for us to do that and combine it with what we also already do really well, and that is qualitative research. So it's really in combining these two disciplines that we can reach the full potential of what you can do with quantitative research. Okay, and now I'm going to hand over to Sixin. For the rest, I'm going to stop sharing.
Thank you, Yang Lui. Can you see the slides that I'm sharing now? Okay, thank you. And thank you, Yang Lui, for giving a very good introduction to the basics of eye tracking and how to use the eye movements to address different questions in translation studies. And I think just one thing to add before my presentation will mainly focus on the practical part, which seems to be, as you mentioned, as Yang mentioned, is a very daunting, maybe at first glance, and also it is a steep learning curve. And Yang mentioned that, when I first started eye tracking research 7 years ago, when I did my master research under the supervision of Yang, at that time I have no idea how to use eye tracking at all. But after 7 years, I was sort of lucky. I mean, to develop some sort of skills in using this tool and find it really useful, I have to say, and brings a lot of opportunities. But I won't take credit for myself. Like I do have to read the manuals and watch videos and sort of have to do a lot of self-learning. But more importantly, I think I am very lucky or fortunate to have received the very rigorous training from all of my three supervisors who are leading experts in using eye tracking in different research, including subtitling and reading. So that is just some background. Okay, my part is mainly focused on the practical part. So that is, if you decide to use eye tracking in your research, how to basically analyze the data and interpret the data and report the data in that aligned with the standard practice in the field, especially if you want to publish your articles in high impact journals. Normally they will have higher standards for the quality of the data analysis and data interpretation and presentation. So that is something that is important to keep in mind. But before that, before I move to data analysis, I want to just emphasize the importance of the conceptualization of research questions and experimental design, because as Yang mentioned, sometimes if you rush to do an eye tracking research without paying a careful consideration, without giving a careful consideration of all the factors in your experimental design, you will likely find out that a mistake you make in the very beginning could be a fundamentally flawed, could turn your study into a fundamentally flawed study, which can be rejected by a lot of articles. So most importantly, before you run into data analysis, etc., or collecting data, be sure that you do the pilot testing, and make sure that your experiment design is scientifically, it is scientific and well informed by theories, etc. The importance of research question and is most important is worth noting that your research study design and the method you're going to use in your study, and also the way you analyze your eye movement data, will all be guided by your research questions. So even as Yang listed all those common eye movement measures in eye tracking research, the way you analyze these eye movement measures, even the same set of eye movement measures, you can analyze it in different ways to address different research questions. So make sure that you develop a very clear and testable research question in the very beginning. So just some criteria for good research question. I think feasibility is a very important one. So you have to make sure, I will go through all these elements, maybe touch on these elements in the remaining slides. But the first one is make sure you have enough time and resources to collect enough number of subjects. That will be important to provide sufficient power for your data analysis. So let's say if you only have a few months to conduct an eye tracking experiment, there's no way for you to recruit enough participants. Then just reconsider the feasibility of conducting an eye tracking research, and also the technical expertise, and that will relate to what type of eye tracker you're going to use. So For example, when I first started my master research, when I have no idea, like no knowledge of eye tracker, at that time I started with a more user-friendly one, that's SMI, which is not available now, but Toby is also a similar user-friendly eye tracker. So for that kind of eye tracker, it won't take you, I mean, it will relatively take a shorter time to master all those skills because all those settings are pretty straightforward. But as a result, they will also give you kind of limited data for analysis. But if you have more time and you have more advanced technical expertise, you may want to move to more advanced eye tracker, like what I used during my 3-year PhD. So with a longer period of time, I have the sufficient time to learn how to develop all those eye tracking programs in those eye tracker, because that take more time to learn, like SR, the iLink eye tracker from SR, and also make sure you have the experiment is manageable in scope. So that is, your research question can indeed can be answered by the eye movement measures or the eye movement data that you can explore from the eye trackers, because different type of eye trackers can provide different eye movement data, or the quality of eye movement data can vary. And other criteria, I think you can just go through it, and because I think Yang Lui have touched on that. And in addition to the research question, it's also important to develop testable hypotheses that are generated or formulated by cognitive theories. So hypothesis basically is a prediction about a phenomenon based on a theory. So if you with a clear set of hypotheses, that will also help you to formulate your research questions clearly. Because ultimately, when you want to use eye tracking to answer a question, you really want to know about a phenomenon, like what is the impact of subtitle speed on the reading of subtitles, etc. And to do that, there are multiple, a number of relevant theories in cognitive studies and cognitive translation studies that you can consult. It is important, before rushing into using eye tracking, is very important. Speaking from my own experience, it's very important to learn, to read up on literature on the basics about human condition, because eye tracking is a useful tool for investigating the cognitive or mental process underlying information processing. So once you collected after you collect the data, you analyze the data, you have to be able to make inference from the data about, okay, what does that tell us about what is going on in the mind? So you have to know some basics about human cognition, like the limitation of cognitive resources such as attention, and some basics about eye movement control, etc. And here are I just list. I don't dwell into details on this into this series, but just give you the reference that you can consult. So the multi-store memory model and the model of working memory is sort of the formal models that give you the basic idea of the basics about our human condition, like limited working memory resources, and how our memory system, like short-term and long-term memory, work and interact with each other. And dual coding theory, cognitive theory for multimedia learning, integrated model of text picture comprehension, and scene perception and event comprehension theory that deals with more with the modality of information processing. If you're more interested in reading, because a lot of our translated content involve reading. So reading is basically a crucial or essential part of the processing of translated content. Then you may want to also have some reading of the model of reading developed by another of my supervisor, Eric Reichel. And drawing on the input of all these relevant theories, we develop another framework called multimodal integrated language framework that basically, hopefully, can provide a theoretical framework for developing testable hypotheses in multimodal language processing situations, such as the reading of subtitles in video, where you have resources from different systems, like the verbal and like the visual system and the auditory system, etc. Okay, now move to data collection. Before data collection, as we mentioned in the beginning, you need to make sure that you have enough time and resources to collect sufficient number of participants. So why is that important to know, like how many participants you need to test? And that is a kind of a common question that people also come to ask me about, like how many participants should I recruit for my eye-checking research? First, before answering that question, we also need to know we need to know the importance of power size. So basically, simply speaking, if you don't have enough participants, let's say you analyze the data and then you find no significant difference between the variables, it's difficult to tell whether it's indeed no effect at all, or it's simply because your analysis is just underpowered. So in other words, your sample size is just too small and not sensitive to the significant effect. So that's why we need to make sure that our data has enough power to detect the effects that we aim to observe. And the sample size is basically determined by statistical power. In other words, the probability of detecting the effect that actually exists, and the effect size, that is how strong the relationship is between your variables, and the type 1 error rate, that is the false positive, that is the probability of conducting there is an effect when there is no effect at all. So normally we set that as 5%. I'm not going to give, overwhelm you with too many details of that, but just to know that just to give you an idea, okay, if you're going to, before you start collecting data, if possible, just it's always suggested to perform an appropriate power analysis prior to data collection. And some recommended tutorials are listed here. So there are some researchers have developed some relatively user-friendly online apps for power analysis. And if you want to do more advanced power analysis using linear mixed effect model, of course, that will be more complicated. Then you also can consult the paper by, for example, Bryce-Bird and Stephen. But put it simply, I think just a quote from Macquarie and Davis. So if I know that a lot of researchers, including myself in the very beginning, may not come from a psychology background, and therefore do not may have a kind of limited knowledge in statistical analysis. So it could be overwhelming in the beginning to learn how to do power analysis. And in that case, a suggestion from Macquarie and Davis is that you can plan to collect data as many stimuli and as many participants as possible. So you can use a standard, let's say, I think in translation studies in the past, mostly the sample size is 12 or 30 participants, but then you can gradually increase it to maybe, if possible, 50 and 60. And from my cases, in my own experiment, of course, we use more stimuli than normally 60 participants can give quite good power analysis. But also it's important to bear in mind, it also depends on the number of variables you're going to investigate in your study, and whether and the interaction effect you're going to observe. So if you're going to observe not just the significant effect of one variable, but you're also going to observe the interaction between two variables, then you also need a larger sample size, because detecting the interaction effect is normally smaller, and therefore we require a larger sample size. And my suggestion will also be, if it's your first time conducting a research, if it's your first time conducting an eye tracking study, then it's always good to start with a simple one. In other words, don't include too many variables, otherwise it will just lead to a mess when you come to data analysis. Okay, so move to data collection, just to make sure you have collected the high quality data in the beginning. During the participant recruitment, it's important to control for some participant related confounding factors, such as their age and especially their eye illness, and also depending on your research question, you may need to control for their language proficiency, etc. If that is not the question you want to answer in your studies, then it's the confounding factor you may want to control. Another important thing to measure to ensure the quality of the data is the calibration. So this is the calibration procedure in SRI link. So I think the calibration procedure are similar for different types of eye trackers, but just with some slight difference in the specific procedures. The general principle are the same. So the good calibration will look like a nicely formed grid like this on the left side, but just that is something you can refer to the specific manual, but just to give you the awareness of the importance of data calibration. And also you need to report the calibration accuracy, like the threshold you use in your calibration in your data when writing up your paper. Okay, once you have the data, what you need to do is check the data, do the data checking. So exclude the problematic trials that can result from, for example, the imperfect calibration failures, and also some coughing on like rubbing noses during the experiment. And always keep a clear record of the excluded data information, and also always important to have a backup of the raw data set before data cleaning. After data checking, you will do the data cleaning, that is to exclude extremely short or extremely long fixation. Again, that depends on your research question. And then you need to export the data file for analysis. So you also need to familiarize yourself with different types of data. So there will also, before that, you need to develop, that is a common term in eye tracking research, the area of interest. That is the area that you want to export the eye movement data on. So you have to be specific about what area you want to define as AOI, and that is what you need to report in the paper as well. And the interest period, and also a different type of output report, because the data can be presented differently in different output reports. So you have to understand the structure of the output so that you can have an accurate interpretation of the data. Okay. So overly short and long-term long fixation will be removed in 3 ways. You can merge the short fixations, and you can remove them using a certain threshold. So that could vary from like a paper to paper, but overall, we will remove fixations that are shorter than 50 milliseconds and longer than 800 milliseconds. But I have to mention that is for the reading part, because fixation shorter than that and longer than shorter than 50 or longer than 800 milliseconds may not indicate that participants are indeed engaged in reading, and that's the reason why we exclude those fixation. For example, they could be doing mind wandering, and then they result in extremely long fixation that could skew the data. But if your research question is on mind wandering, then there's no need to exclude those extremely long fixations. So you can also discard the data points based on the standard deviation as well. If you exclude any data, always important to report them clearly, like as how the percentage of data loss. Okay, come to data analysis 2. I think I'm not sure how many of you use R, or some of you may use Python, but because I use R, so I'll just share here some basics about R. So it's basically an environment for statistical analysis. So there are a lot of very useful free tutorials on how to use R. So I would suggest just to watch those tutorials to at least to know some basic language that you need to use in this R environment. So the scripts are just the language you use to communicate with the environment to manipulate the data and analyze the data. So, just a few steps. I'm not going to give, because of the time limit, I'm not able to give details in each step, but I just give the overall direction, the overall procedure, and then when you indeed do an eye checking research, that will be the guidelines that you can consult. And the first is, if you do the data analysis, you have exported the eye movement data, and then you start doing analyzing in R. The first is clear the workspace, so all the previous data will be removed, so it won't mess with the existing data file, and then load the packages. So different packages will provide different functions for different types of data analysis and data manipulation. And import the data. Let's say, for example, after you load this package, you can use certain functions to read the data file and read different type of data file. And that is also, I think, it's good to know that before we moved into, all those more advanced skills, data analysis skills, it's always beneficial to also to familiarize yourself with some basics in data analysis, like what are the basic type of data, and then what are the basic types of data file, and all this will provide a good foundation for your data analysis in R. And then you can view the data using different functions. And most of the time, we also need to transform and manipulate the data. For example, normally the data file, especially if you collect like a large sample size, the original data file can be very large and occupy a lot of space. So some of your data analysis may only use or draw on 1 or 2 eye movement measures. Then in that case, you can trim the data file, just because if you run a really large data file in your analysis, it will take a lot of time. And if you trim it, it will be more efficient. So the trimming of the data, and then all this manipulation, transforming of the data can be done in R easily once you get to know how to use it. I have to say, it's a steep learning curve in using R, but it's really rewarding experience, because it's not just very useful for data analysis, it's also very useful. I mean, not just useful for analyzing eye movement data, it's useful in manipulating and analyzing all type of eye movement, all type of data, like the data from the survey, questionnaires, etc. It saves a lot of manual work. And what we generally need to report in publications are the descriptive statistics. So that is the means, which means the average of the set of observations and the standard deviation. So the variability of the data, or variation of the data. And how to make ChatGPT as your friend. I guess a lot of you already use ChatGPT for different purposes in your life. And for me, I found it particularly beneficial in data analysis, but only, I think it's mostly useful for visualizing the data. So here is the prompt I gave ChatGPT to plot a data for me. So I have to specify what variable I have and what levels I have, and then ask ChatGPT to plot the mean and standard deviation for me. Of course, ChatGPT will only give you a sample data set, but you can always manipulate, replace the sample set with your data set. But that also based on a good understanding of the basics in data structure, so that you need to know where to make the changes and how to make those changes. But it's very beneficial ChatGPT is very beneficial in developing this specific complicated codes for data visualization. But in terms of data analysis, like fitting the model, which I will touch on later, it's not that reliable. So, and also I realized that ChatGPT does not always, as in other cases, give you always the perfect answer. So you can just use it as a reference point and try it, but it doesn't not necessarily always completely reliable, but save a lot of time, because in the past I have to develop all these codes on my own and go to a different forum. But now I can just go to ChatGPT and then manipulate the codes, and then everything become much easier. Okay, and then before fitting the model, we need to visualize the data. And setting up the contrast, basically that allows you to see what combination of what levels of variables you want to combine. And this is a little bit complicated, I think, for some of you who have never done data analysis before. But just again, it's just like to give you the awareness of the importance of this kind of steps, so that you know this is what needs to be done. If you in the future, if you need to do an eye tracking research. And yeah, and here's a useful paper that you can consult in terms of setting up the contrast. It's important, I think. The importance of setting up the right contrast is because it can help us specify the hypothesis you want to test. And also the interpretation of the model outputs also depends on the specific contrast you use. So if you set up in other words, you set up in the beginning the plan how different levels of the variables need to be compared, then in the model outputs, have a better idea of how to interpret the difference between different levels of variables. Finally, almost finally, when using the statistical analysis methods, there is a trend, or there is a shift from traditional ANOVA analysis to linear mixed effect models analysis, which we call LMNs. And there's a reason behind that, because LMNs are generally more advantages compared to ANOVA analysis. And one significant benefit is the number of data points it can handle. So in a traditional ANOVA analysis, we generally use the average mean in one condition for one participant. So that will lead to a loss of a lot of data points, which can lead to a reduction in the statistical power. But LMM can handle all the data points from each participant in each condition, and it can also account for individual the variance result from participants or result from the stimuli. So that's why it's become powerful. So I will highly recommend you, even you are not doing eye tracking research, but that is the trend. I can see that in the future, that will be, ANOVA analysis is likely to be replaced by LMM. So sooner or later, we all need to know how to use LMMs. Yeah, I'm not going to give details in this, and there again a lot of very useful tutorials on how to analyze data using LMMs. And for this, once you fit the model, you need to compare the model, and you need to check the distribution of the residuals. All those are technical terms. We will get used to it when you collect the data and analyze the data on your own. And speaking of my own experience, is the fastest way you learn how to do analysis. You really collect the data, and you can also using data from other people, researchers. There are a lot of, in open science framework, researchers are encouraged to share their R scripts and share their data in a repository, so you can just use their data file and then play around in R, and that is the fastest way for you to get familiar with all these terminologies or the terms, technical terms and technical skills. And in terms, once you get the model output, the standard practice, we need to follow the standard practice in reporting the model outputs. For example, by providing a summary of the final models in data analysis. And that is also a suggestion from Macquarie and Davis. So we need to be assured that there is no single correct way. And that is also what I really agree with. There's no one single correct way to implement an LMMs, and there's no one single correct way to do data analysis. But the choice we make during data analysis is only one path, but it should be justified among multiple alternatives. In other words, if you choose to do the data analysis in this way, you have to justify why it's robust in this way and why it should be done in this way to answer your research questions. So as long as it can be justified, it's fine. And here are some recommended tutorials, and this book is the one that I highly recommend for beginners because it really provides a comprehensive step-by-step guidelines on analyzing data in R. So if you have time, just have a read of this one, and also the article by Macquarie and Davis in 2020. And some useful forums that you can consult, but I think ChatGPT is a great help now. But I also find out there are some questions that ChatGPT cannot answer, but I found answer in these forums. Okay, I think that's all. And if you have any questions now or in the future, maybe most likely in the future, you feel free to drop us an email. Yeah. Should I stop sharing?
Yes, if you like. Thank you very much,
Okay.
Sixin. Thank you, Yan-Louis. We're happy to take questions and comments. Please use the chat option to share your comments and the questions. While waiting for comments and questions from participants, Yan-Louis, I'm sorry, I have very beginner questions for you. One of them, the first one, I think you have already answered it when you spoke about the limitations of eye tracking. I was wondering how we can distinguish between fixation that is meaningful and just fixation that's just a distraction or an indication of someone thinking about something completely unrelated to the experiment. So when you were talking about the limitations, you said there's no way that we can be sure that what we see on screen, that it's say in terms of eye movement, is what the participant is thinking about. Is that correct? Is my understanding correct?
Yes. No, I think so. The thing is that there is a large body of literature on eye movement control during reading, for example. So we know what eye movements look like when people are paying attention to a text when they're reading it. So if you, for example, we know that words that are less common, people are going to have more fixations, the fixations will be longer. And so if you see somebody reading a text and there's no word frequency effect, they look at all the words the same duration, then you know they're not really paying attention because they're not really processing it. The same way, if somebody just stares at a particular point on the screen for a long time, for a second or more, then you know their mind's wandering. They're not paying attention to what they're looking at. So there are ways. So I was maybe a bit too strong to say there's no way. What I mean is that you can't always assume that when somebody is looking at it, that they are actually cognitively processing it. But the way they look at it can give you an indication of whether they are processing it. Because if they are just staring at one point, you can almost be certain that they're not extracting information anymore. They're just thinking about something else. And you know, from reading, sometimes you read a text and you go through 2 pages and then you realize, but I can't remember anything that I read. And you have to go back and you reread it. And it doesn't mean you weren't reading it, but you weren't really processing it. You were thinking of something else while you were reading it. And your eyes were just going through the text. You still looked like you were reading. Anybody looking at your eye movements would think you are reading, but you're not quite processing what you're reading. So in cases like that, and there is actually quite a lot of work being done now on using eye movements to measure comprehension during reading. So to say it's not always reliable to use post hoc measures like comprehension tests, but because we know what skilled reading looks like, if we can analyze the way people read a text and we can see that the eye movement patterns differ from what it should look like, then we can say, no, they're not paying attention or they're not understanding what they're reading.
Thank you. And by the way, if anyone would prefer to speak, I mean, rather than chat with Yan-Louis and Sixin, you can just unmute yourself and ask your question or make a comment. My second question, you mentioned dwell time and fixation duration. Again, from the point of view of someone who didn't know anything about eye tracking, the two concepts sounded quite the same to me. Is there a difference between them?
Yes, I mean, a fixation duration is just one fixation, the duration of a fixation, whereas dwell time is you make a sum of all the fixations on a word, for example, will be the dwell time on that word. Whereas fixation duration will just be the duration of any single fixation.
Thank you for that, Yan-Louis. And my last question is about word skipping and reading rate. So word skipping, I understand, it's when apparently the participant skips words. Now, what about, let's say, a group of participants with varying reading rates, where, for example, one goes very fast and some are slower? How can we determine whether it's just a reading rate or someone actually skipping words? Does my question make sense?
Yeah, I mean, I think if somebody reads really fast and efficiently, then you will expect them to probably skip more words. I mean, if you compare the eye movements of a beginner reader to that of a proficient reader, then a beginner reader will tend to fixate every single word and look at it for longer to recognize it and to process it. So you can expect that word skipping will give you an indication of the efficiency of the reading, but it really it's not always that simple, because if you people have different reading speeds. So you can have two people who are equally proficient readers, but one is just a faster reader than the other. So in cases like that, it's probably useful to have a baseline, to have somebody just read the text and then do your experiment with them comparing them to their own baseline rather than comparing them to somebody else, depending, of course, on what you think is important. But with eye trackers that we have now, it is possible to actually see exactly which words were skipped, how many words were skipped, how long the fixations were, so that you can combine all of that with the speed. So speed in itself does not necessarily equate efficiency. I don't know if that makes sense. Sixin, I don't know, do you agree?
Yeah, I agree. And just something to add is that is a valid point. Like, for example, if your research question is, let's say, if you want to see whether participants skip more words when reading human translated text versus machine translated text. So if that is your research question, you manipulate the text type. But my understanding of your question is there could be some cases like it's not the condition we are manipulating, not the text we are manipulating that cause the difference. It could be the cases that some participants, they just skip more, they're fast readers, so they skip more words. So how can we tell? And that's why it's really useful. I mean, linear mixed effect models are really useful here because it can account for the individual difference. So in the random effect structure, we specify already the different the variability in the intercepts for different levels of the variables. So, for example, some participants, they are faster readers compared to other readers. So they will be faster in reading both type of tests, and we account for this kind of variance, and that will give a more robust result. And that's why there's a trend in shifting to linear mixed effect model. I mean, from traditional ANOVA. Yeah.
I can maybe go to some of the questions in the notes, in the comments, chat, I mean.
Anita says, general question, but what other technologies are frequently used in PI research studies?
Yes, so Anita, that is actually, there are quite a few measures. I think eye tracking has become really popular because of the fact that when we translate and interpret, we tend to look at things. So that's quite useful. But of course, there are other methodologies that are used and sometimes triangulated. We have used EEG, electroencephalography, for example, that gives you an idea of the magnetic signals, electrical signals of the brain. These things are much harder to interpret. There's a lot of noise. I mean, when you blink, there's a huge noise that you have to filter out. For example, when you move, any muscle movements will create noise. But it is something that can be used really effectively if you know what you're doing. I can't use it myself. You need some significant training in the use of imaging, brain imaging, to be able to do that. But there are quite a few people who are doing more neurological studies using brain scans and EEG and FNIRS and all kinds of scanning. Other technologies that are used are things like galvanic skin response and heart rate monitoring, cortisol levels. So there are all kinds of physiological measures that can be used that give you an indication of people's arousal, people's levels of anxiety, for example. Eye tracking is just one of those measures. I think it's probably one of the easier things by comparison to use because of the eye-mind hypothesis that you can make that link. I hope that answers that.
Thank you very much. And Sixin has also shared the further information in the chat.
That is a good review article of the research method, including eye tracking in translation and interpreting studies. So it's in a book published in 2023.
Excellent. Thank you.
Thank you. A question from Yagwan. He says, thank you for your wonderful sharing. Can I ask, when conducting eye tracking research, would you choose participants based on their English proficiency? And I think you've said something about this, Sixin. How do you distinguish between mind wandering and the lack of understanding?
Yang Lui, do you want to go for first or what?
No, I mean, I can quickly do the English proficiency, then I'll give you the other one. I mean,
you give me the difficult one.
No, and I think they both not that difficult to answer.
Okay.
The English proficiency, it really depends. I mean, sometimes you choose people with varying levels of English proficiency because that's one of your variables. That's one of your factors that you want to control for, you want to test. You want to see to what extent does English proficiency impact, for example, comprehension during reading. So you can vary that. If that's not what you're interested in, then, and we often do that, we want to see how people read subtitles at different speeds. Then we want to control for English proficiency, and then we make sure that they're all first language speakers or they're all second language speakers. But first language speakers, even if you use only first language or only second language speakers, sometimes you have to do some kind of a test of proficiency in order to make sure that you don't have a wide range of proficiencies in the same group. Otherwise, that becomes a confounding variable. Sixin, over to you.
Yeah. For the English proficiency one, I just agree with what Yang shared, and something to add is that it depends on your research question. So simply speaking, if language proficiency is, if you want to know whether language proficiency may also affect the, will have a significant effect on the dependent variable, then you may not want to control for it, and you may want to include like a wide range of language proficiency so that you can see the difference, see the significant difference. Otherwise, if it's just a narrow range, like if you only recruit intermediate English learners, that it's very likely that in the model, first, it's very possible that it won't converge. The model will not give you the robust results, and also even the model converge, then it may not be significant result because there's a very narrow range of the language proficiency. If that is your research question, then you don't need to control it for. But if it's not, then as Yang suggested, you need to control for the English language proficiency. And for the second question is, how do you distinguish between mind wandering and a lack of understanding? And my understanding, but that is a very broad question, because my understanding of the lack of understanding is, are you indicating like a process comprehension difficulties, and whether that can be indicated by the eye movements? And yes, and as Yang mentioned in his presentation, there are a number of eye movement measures that we can use to investigate whether participants are encountering more processing or comprehension difficulties when reading the test. For example, if they make more regressions, and if they skip less words, do less word skipping, and if the scars become shorter, then likely, they have more reading difficulties. And especially regression is one of the commonly used measures to measure, to reflect comprehension difficulties. But it's also important to know that sometimes we can't make a definite conclusion based on one single measures. So we always need to, we draw on multiple eye movement measures. But on the other hand, it's also important to bear in mind that you can't use a long list of eye movement measures and see, from which eye movement measure I can have the significant result, because likely the more measures you use, then you will likely have the type 1 error, that is the false positive error. So you need to be careful in mindful in selecting the exactly the right set of eye movement measures in answering this question. And for specifically mind wandering, that requires specific intervention in your study design. For example, you need to set up a prompt. For example, when they are doing the reading, you need to set up the prompt in some random time period, and to see whether during that period they experience some mind wandering, as for example indicated by a reduced work frequency effect. Because as Yang mentioned, if they are indeed engaged in reading, then normally we should observe work frequency effect. But if the work frequency effect reduced, then they tend to be less engaged in reading, which might indicate the mind wandering phenomenon. But it's a little bit difficult, different from the lack of understanding. But sometimes they could be it is not completely impossible that they are not correlated, because you can do mind wandering because you have, if this test is too difficult to process to the extent that you may start to do the mind wandering, that could be possible,
Thank you both. And probably the last question, how do you see using eye tracking technology to study cognitive load processing or cognitive processing in consecutive interpreting? And what is the challenge in it?
Oh yeah, it's not an easy question to answer. If we're looking at eye movements, as I assume that's what the question is about, how can you use eye movements in consecutive interpreting? Now, if interpreting, it is tricky to use eye movements with consecutive, and this is an ex-PhD student of mine, Sijia Chen, has worked on note-taking during consecutive interpreting, and she did look at cognitive load there as well. And that would be simply, you would need to look at their eye movements while they're processing their notes. So that gives you quite a good indication. So there you can look at something like fixation duration. The mean fixation duration would give you an indication of cognitive load. The number of note units they look at. You can look at things like the time span between looking at a note unit and delivering the interpreting. You can look at how they process the text. They tend to read ahead on their notes, of course, in order to get, because it's a prompt for memory, of course. So in consecutive, I think it's easier to use eye movements for cognitive load than it is in simultaneous interpreting. Simultaneous interpreting, especially with our text, you kind of, the only way you can use eye movements there is really looking at pupil dilation to see whether the pupil diameter changes, and that could give you an indication of cognitive load. But in consecutive interpreting, because there is also visual input in the form of textual input, that can give you an indication. The thing is, there is still a lot happening in the mind during consecutive interpreting that isn't linked to visual input. So in consecutive interpreting, a lot of what you're doing is remembering what was said. So you listen to the source chunk and you try to memorize that and formulate the translation of that in your head. So it's a really complex thing to do, but it is possible to use eye movements there by simply looking at the way that fixations behave during the reading of notes in consecutive interpreting. I hope that answers it.
Thank you, Yan-Louis. Would you like to add something, Sixin?
No, I think Yan-Louis, because that is not the field I'm working on, so I think Yan-Louis is in a better position. Yeah.
Okay. Thank you very much. Thank you both. And I'll be reaching out by email to thank you formally again.
That's fine. Thank you very much for having us.
Yeah, thank you, Mr. Fan.
Thank you.
And thank you, everyone.